plus cosine 2x squared equals 1. You got to find, this is the one where it's find the exact solutions in the interval, not including 0, yes including 2 pi. And this is one of those ones where you just have to remember absolutely everything we've done ever with trig and all your fraction rules. Yes?
When I was doing the homework, I tried doing like an odd one to make sure like I know how to do it right. And I looked in the back to find the answers, and they had zeros in them.
Which is interesting, because...
Yeah, so I wasn't sure if that, like, they were just mistaking, or if we were, like, reading it wrong.
No, that's how we're reading it.
Mr. Belleville, you still have not told me how you pull those cosines out of your ass, even though they shouldn't be there.
I explained it yesterday.
Well, hold on a second.
Is there a way to move this camera up so it don't...
Yeah, it does tilt. Or you can
It's
just
not tilting a lot.
lower the back one, like that. Would that help?
Yeah.
Okay.
Really.
That's my fastest way, too. Okay, hold that thought a sec. Let me do this one first, and then I'll go into that. Got a lot to do today. This one, there's no way around foiling. And when I foil this, it's going to be sine squared 2x plus 2 sine 2x cosine 2x plus cosine squared 2x equals 1.
Whoa.
This is just what you get anytime you foil A plus B. Bless you. Okay?
But
You're going to get the first thing squared, the product of the two terms doubled in the middle, and the last thing squared.
can you just factor out 2 now?
No, you can't factor a 2 out of inside of these. That's what I've said a bunch of times. I'll need to say it like every day, because taking the sine and cosine aren't operations. They're not multiplication, division, subtraction, or addition. That means order of operations doesn't apply. That means the distributive property doesn't apply. It's true of logarithms also. So you can't take it. You cannot take these 2's out. Here's what you can do, though. I'm going to rearrange the order a little bit. I'm going to write this as sine squared 2x plus cosine squared 2x plus 2 sine 2x cosine 2x equals 1. Okay. Does this look at all familiar from when we were doing the trigonometric identities?
Yeah, because you can. Well, they're like the same thing, just cosine and sine.
Sine squared, cosine squared equals 1.
Sine, yes, that's the one I'm looking for. True, but that's the one I'm looking for. There was a rule we said where sine squared of anything plus cosine squared of that same thing always equals 1.
So you just make that 1 then.
Yeah.
When it has a 2 in front of it.
Doesn't matter as long as it's the same thing in both cases.
So then the answer would be 2?
Well, no, so then this is 1 plus, you can just replace it. It's a straight substitution.
That 2 is not really even a number, it's just part of it, right?
Yeah, it's like if I were saying this were theta,
Okay.
and then I was saying theta equals 2x in here.
So you ignore the 2's as long as they're all 2's.
As long as they're all 2's for that identity, yes.
So then you can like subtract the 1, so then it's like that 0 equals.
Yes.
thing.
2 sine 2x cosine 2x equals 0. Yes, Sam?
Okay. Is that line under that division? Because it's screwing me up.
Oh, I'm sorry, it's not division. It was just to separate it. Would parentheses be better?
Sure.
I was just trying to indicate it.
Mathematically correct.
Parentheses are fine. They're correct.
Underlining.
Underlining is not a math operation, but... Okay,
And don't we have
does this look like one of the new formulas we just went over?
sine x cosine x? 2 sine x.
Right. The original one was 2... No. Let me write it correctly. The other formula we need is sine theta...
Equals.
I'm sorry, sine 2 theta equals 2 sine theta cosine theta. This is the one that bothers Jesse, where the cosine seems to magically appear. This is the sine 2 theta equals 2 sine theta cosine theta. Okay? Doesn't this look like this side? Okay? Now here's the magical part, and this is where this substitution you were just talking about, Saul, comes in handy. Whatever this is, I can use these formulas forward or backwards. So if I'm going to use this one backwards, then I've got to picture that these thetas are like the 2 x's. Okay? And then this 2 is right there. So I can make this into sine 4x equals 0. Because this formula is the same as the right side of that double angle formula.
Actually, no, never mind.
But you can't do that.
No, I can do that.
How can you? Yeah, how can you do that? Because you
Combine
have the
sines and
cosine.
cosines.
Okay.
So
The short answer is, you know how the cosine magically appears out of this formula because it's a difference between 2 theta and theta?
No.
Oh, so you're just okay. You're taking.
I'm doing it backwards.
You're substituting sine 2 theta for 2 sine theta cosine theta, so that
Yes.
you just get that leftover 4.
Yep, since my thetas are 2 x's, when I double it, it'll be 4 x's.
Okay, that makes sense.
Mr.
Okay,
Douglas.
yes.
So can you add cosines and tangents like that, or?
No, it's different for every function. There's a unique formula like this for every one. That's why I remember cosine had 3 of them. The cosine 2 theta actually equals cosine squared theta minus sine squared theta.
Isabella,
So it's a different pattern for each.
I think I know. Actually, I know the answer to this, but
Right.
what does cosine actually mean? What does sine actually mean? Like the actual definition of it.
Here's where it gets weird. That's a good point. Matt, follow me over here a sec. Okay, I'll solve this one in a sec, but... Okay. Now, here's this world's fastest, shallowest review of anything, okay? Cosine and sine originally mean, if you have this triangle A, B, C, and this is capital letter angle A, okay? The sine of angle A is just the ratio of the opposite side to the hypotenuse. That's what it originally meant. And for thousands of years, this was fine. The ancient Greeks used this to make sure their temples went up straight. They used this to say, hey, I want to know how tall that cliff is. And they would use just knowing this. Like on the last problem, the word problem about how tall the building was, most of you got right. For thousands of years, this was okay. René Descartes comes along and invents the Cartesian coordinate plane, and as long as you stay in quadrant 1 and call that x, that y, and that 1, all the rules you learn in geometry still work. But then, when you start treating this as a radius and spinning it, that's where the new set of rules we learned last year about the unit circle kick in. Now, these new and that's where these things start to take on a different meaning. So, it kind of depends on what you're doing. If you're building a temple in ancient Greece, this is all you need to know about sine. Okay? If you want to design, in the 20th century, an echocardiogram, or a radar, or a microwave, or something, then you want to talk about sine as being like this, which is the graph you get